Good morning, children. So today you are going to learn one of the most important theorem, that is called the midpoint theorem. So the statement is given that prove that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. So this is a very important statement. So this is, in short, this is called the midpoint theorem. So now here it is given that prove that the line segment joining the midpoints of two sides of a triangle. So the triangle is ABC. Here two sides D and E. So the sides are AB and AC. There D and E are the midpoints of the sides AB and AC. So here midpoints of two sides. So here they have given two sides. So the two sides are AB and AC. So there D and E, these are the two midpoints of the sides AB and AC. So the line segment, that is DE. So prove that the line segment, that is DE, joining the midpoints of two sides of a triangle. So the triangle is ABC. These are the two midpoints of the sides AB and AC. So this line segment should be parallel to the third side. So this is the third side. This is BC is the third side. This is the first side, second side, and this BC is the third side. So the line segment that joins the midpoints of the two sides, so this is the line segment, that is DE, must be parallel to the third side. That means you will prove that that is the line segment parallel to the third side and is half of it. So that means you will prove that DE, so it's parallel to BC. BC is the third side and is half of it. That means you will prove that DE equals to half of BC. So you will prove this true. So from the statement. So it is given that prove that the line segment joining the midpoints of two sides of a triangle. So the midpoints are D and E. So these D and E are the midpoints of the sides AB and AC respectively. And here BC is the third side. So by joining these midpoints, you have got the line segment DE. So this DE must be parallel to the third side. So parallel to the third side. So BC is the third side. So DE parallel to BC and is half of it. So the DE should be half of BC. So you will prove this true. Now to prove this, you have to take the construction. So the construction, what you will do is, so here you will extend the line segment DE to a point, say F, such that DE equals to EF. So you will extend DE to F. So DE to F. So say this is point F, such that DE equals to EF. And then CF is joined. You will join CF. So this is the construction part. So here now, say the given is, so let ABC be a triangle, in which, so here prove that the line segment joining the midpoints of two sides of a triangle. So the two sides AB and AC, D and E, these are the two midpoints of AB and AC. So you got, by joining these two midpoints, you have got the line segment DE. So DE should be parallel to the third side. So the third side is BC and DE should be half of BC. So that means here in which D and E, so D and E are the midpoints, of AB and AC. So AB, so D is the midpoint of AB and then E is the midpoint of AC, of AB and AC respectively. Now to prove. So you will have to prove that, so the line segment that joins this midpoint D and E, that is DE, should be parallel to the third side. Which is the third side? BC is the third side. So you will prove that this line segment DE that is obtained by joining these two midpoints should be parallel to the third side. N is half of it. That means to prove that number 1 DE parallel to BC. Number 2, you will prove that DE equals to half of BC. So these are the two things they have told to prove. And this statement is called, in short, it's called the midpoint theorem. So normally you will write this one only. So but the statement is this. So this complete statement in short, this is called the midpoint theorem. Now comes construction. So what you did, you have produced DE to F such that DE equals to EF. So these two you have made equal, and then CF is joined. So produce DE to F, DE to F such that DE equals to EF, and then CF is joined. So CF is joined. So is joined. Now you have to proceed step by step. So here proof. Now comes the proof. So first you will make these two triangles congruent. So we will make these two triangles congruent. How? Here E is the midpoint of AC and D is the midpoint of AB. So here in these two triangles, that is a triangle, in the triangle AED, so AED, and the triangle CEF, so CEF. So in these two triangles you will get AE equals to CE, so AE equals to CE, so AE equals to CE. Why? Because E is the midpoint of AC. This one is given. D and E are the midpoints of AB and AC. So E is the midpoint of AC. That is why these two are equal. Then you got DE equals to EF. So here DE equals to EF. So DE equals to EF. This is through construction. You have made it through construction. So DE equals to EF. So this is through construction. And then you have got these two line segments AC and DF meet at point E. That is why these two angles form a pair of vertically opposite angles. That is why these two angles are equal. So you will get angle AED equals to angle CEF. So CEF. This is due to vertically opposite angles because line segment AC and DF meet at point E. So this is vertically opposite angles. You have got the three conditions. So 1, 2, 3. So therefore, triangle AED congruents to triangle CEF by, now in this triangle you took the side AE and you took the side DE and you took the angle AED. So you took this angle. So you took this side, you took this angle, and you took this side. So side, angle, side. So by SAS, these two triangles are congruent. Since these two triangles are congruent, you have got AD equals to CF. So you got AD equals to CF. That means as these two triangles are congruent by side, angle, side, so by SAS you got it. Therefore you have got that AD equals to CF. So AD equals to CF. This is by CPCD. This is by CPCD. Let us take as equation number 1. But you got AD is equal to DB. Why? Because D is the midpoint of AB. Because you got here that D and E are the midpoints of AB and AC. So D is the midpoint of AB. So these two segments will be equal. So you got AD equals to BD. This one is given. got that. So in place of AD, you can write CF because AD is present in both the equations. So in place of AD, you can put CF. So CF equals to BD. So you got CF equals to BD. Next, as these two triangles were congruent, so you got now one is this, that CF equals to BD, CF equals to BD, so you got these two opposite sides equal. Then you have met, as these two triangles are congruent, so you got that angle A corresponds to angle C. So angle A corresponds to angle C. So these two angles will be equal by CPCD because you made triangle AED congruent to triangle CEF. Since these two triangles are congruent by SAS, therefore you got these two angles also will be equal. So here angle A corresponds to angle C. But they form a pair of alternate angles, alternate. That is why CF is parallel to AB. So you got here that CF is parallel to AB. So you got CF is parallel to AB. So CF is parallel to AB means you can say that DB is parallel to AB. Sorry, CF is parallel to, so AB means you can say now DB. Now you see, here you got CF equals to BD. So CF equals to BD. CF is parallel to BD. CF is parallel to, so CF is parallel to BD. So in this, there is quadrilateral BCFD, one pair of opposite sides equal as well as parallel. How? You got here CF equals to BD, CF and BD equal. Again you got CF is parallel to BD, CF is parallel to BD. That means you got one pair of opposite sides equal as well as parallel. That is why BCFD is a parallelogram. If this is a parallelogram, then the opposite sides are also equal and parallel. That means DF is parallel to BC. Because BCFD is a parallelogram, because one pair of opposite sides equal as well as parallel. That is why the opposite pair of sides are also equal and parallel. That is why DF is parallel to BC. If DF is parallel to BC, that means DE is parallel to BC and DF equals to BC because they are the opposite sides of the parallelogram. So in this way you will proceed. Now, you will make these two triangles congruent. So, in triangle AED, so AED and triangle CEF, so CEF. So, you have got that AE is equal to CE. So, AE equals to CE. So, AE equals to CE because E and D, these are the two midpoints of the sides AD and means AC. That is why AE is equal to CE because E is the midpoint of AC. Since E is midpoint of AC, then next you got that these two angles will be equal because the line segment AC and DF meet at point E. So these two angles will be equal. They form a pair of vertically opposite angles. So angle AED is equal to angle CEF. So CEF, it is vertically opposite angles. So they form a pair of vertically opposite angles. Then you got DE equals to EF. So DE equals to EF. So since this is true construction, DE equals to EF, you have got it through construction. So this is through construction. So now you have got the three conditions. So you got these three conditions. So now these two triangles are congruent by side, angle, side. Therefore, triangle AED, so AED congruent to triangle CEF, so CEF by SAS, so by side, angle, side. So as these two triangles are congruent, so their corresponding parts are also equal. So therefore, you will get that AD, so you will get AD is equal to CF, so AD and CF are equal. So AD equals to CF. So AD equals to CF. This is by CBCD. So this is equation 1. You have got it by 1. Again you got that AD equals to DB. So AD equals to DB because D is the midpoint of AB. So AD equals to DB. AB equals to DB since D is midpoint of AB. So this is equation number 2. So from 1 and 2, so from equation 1 and equation number 2, you get, so you compare these two, you will get, so in place of, so as these two sides are equal, so these two also will be equal. So you will get CF equals to DB. So you got CF equals to DB. So now your main objective will be to make BCFD parallelogram. What you will do? As you got CF equals to BD, you try to make CF also parallel to BD. If one pair of opposite sides equal as well as parallel, then the figure will become a parallelogram. If that figure becomes a parallelogram, then the opposite pair of sides will be equal as well as parallel. So now again you see, you can take here 1, you can take here 2. So as these two triangles are congruent, therefore angle A corresponds with angle C. So these two angles also will be equal. And angle 1 is equal to angle 2. This is by CBCD because you made the triangles congruent. Now, therefore, they form a pair of alternate angles. So these two angles, they form a pair of alternate angles. That is why CF is parallel to AB. So AB is parallel to CF. Because these two angles, they form a pair of alternate angles. That is why CF is parallel to AB. So now this gives, so it means AB is parallel to CF. That means BD is part of the segment AB. That is why you can say that if AB is parallel to CF, then DB is also parallel to CF. So here DB is parallel to CF. You can take this as equation number 3. Now you take, this will be equation number 3 and this will be 4. So from 3 and 4, you have got that CF equals to DB, CF equals to DB, and from 4 you got CF is parallel to DB. So CF is parallel to DB. That means one pair of opposite sides equal as well as parallel. So from 3 and 4, from equation 3 and equation 4, you have got that one pair of opposite sides equal as well as parallel. Therefore, quadrilateral BCFD. So BCFD is a parallelogram. Now, when BCFD is a parallelogram, that means the opposite pair of sides are equal as well as parallel. So therefore DF is parallel to BC, which means DE is parallel to BC. DE is parallel to BC. So you have got the first part. That means the line segment joining the midpoints of two sides. So AB and AC, D and E midpoints. So by joining this D and E, you got the line segment DE. So this should be parallel to the third side. That means DE should be parallel to BC. So you got DE parallel to BC. N is half of it. So DE should be half of BC. N. So DF equals to BC. So DF equals to BC. Why? Because opposite sides of parallelogram. Opposite sides of parallelogram are equal. So equal. That is why. Then the last part is, so this gives so now DF, DE plus EF. So DF means DE plus EF equals to BC. Now you have made it through construction that you have produced DE to F such that DE equals to EF. You have made it through construction. So that is why here DE plus. So in place of means EF, you will write DE. So it will be DE equals to BC. Why? Because since DE equals to EF, so DE equals to EF. So you have made it through construction. So this gives twice of DE equals to BC. So the last step will be DE equals to half of BC. So it is proved. So here DE parallel to, so DE is parallel to BC. That is the line segment joining the midpoints of two sides of the triangle is parallel to the third side. So the BC is the third side. So you have proved DE parallel to BC and is half of it. That is DE equals to half of BC. So DE equals to half of BC. So here what we did, the first point keep in mind, you have made construction that DE extended to F such that DE equals to EF and that CF is joined. Then the proof part, first part you did, you have made these two triangles congruent. AE equals to CE, E is the midpoint of AC, DE equals to EF, this is through construction, and these two angles are equal, vertically opposite angles. So these two triangles we have made congruent by side angle side. That is why AD equals to CF by CPC. But AD equals to DB. Why? Because D is the midpoint of AB. Then you got DB equals to CF. Again, as these two triangles you made congruent, that is why angle 1 is equal to angle 2 by CPCT. They form a pair of alternate angles. That is why CF is parallel to AB. If CF is parallel to AB, that means CF is also parallel to DB. Then now you see you have got that CF equals to DB and CF is parallel to DB. One pair of opposite sides equal as well as parallel. Therefore, DCFD is a parallelogram. That is why DF is parallel to BC, because in a parallelogram, opposite pair of sides are equal as well as parallel. That is why DF is parallel to BC, which means DE is parallel to BC. Again, DF equals to BC, opposite sides of parallelogram. So DF equals to BC, opposite sides of parallelogram are equal. Then this DF you make DE plus EF equals to BC. So in place of EF you got DE because they are equal. Then you got DE half of BC. Hence DF is DE parallel to BC and DE half of BC. So it is proved. Let us take exercise 8.2. 8.2. Let us take question number 2. So it is given that ABCD is a rhombus. P, Q, R and S are the midpoints. Of the sides AB, BC, CD and DA respectively. Now to prove PQRS. So PQRS is a rectangle. So here the questions are more important. ABCD is a rhombus. So let us draw one rhombus where all the four sides are equal and the diagonals of a rhombus bisect each other at right angles. So here let us draw the diagonals first. So in a diagonal, the two diagonals means unequal. So one is the longer, the other is the shorter. That is why you have taken the shorter one this side, you have taken the means longer one, and then you have joined it. This is a rhombus. So here they have given that ABCD is a rhombus. So ABCD. So this is a rhombus where all the four sides are equal. P, Q, R and S are the midpoints of the sides AB. So P is the midpoint of AB. So let us join it in this way. So here P is the midpoint of AB, Q is the midpoint of BC. Then here R is the midpoint of CD. So here CD, so R is the midpoint, and then S, midpoint of the side AB. Now here they have said that you are to prove that the quadrilateral PQRS should be a rectangle. So to make it a rectangle, you are to make the opposite pair of sides equal. That means PQ equals to RS and RQ equals to PS. First condition. Next condition is that you are to make any one of the angle, that is either P or Q or R or S, to be 90 degree, because in a rectangle the opposite pair of sides are always equal and you will get each of the angles 90 degree. So just to make one of the angle, either you make P or Q or R or S 90 degree and then the opposite pair of sides equal. That time this will become a rectangle. So here, as they have given that ABCD is a rhombus, so this is a rhombus ABCD. So you know that the diagonals of a rhombus bisect each other at right angles. So this will be 90 degree because the diagonals BD and AC bisect at O at right angles. So at this point O, it will be 90 degree. Let us take here one same name. Say it is N. It is say N. You can take anywhere. Now here, as we proved the earlier theorem, that is the midpoint theorem, that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Let us take the triangle ABC. So here P and Q, midpoints of AB and BC, because they have given P, Q, R and S are the midpoints of the sides. So these four are the midpoints of their sides. So in the triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. Therefore, in this triangle, so you got that the line segment joining the midpoints of two sides of the triangle. So the triangle is ABC, and these are the two sides where you got the midpoints P and Q. So by joining this midpoint, you got PQ So this will be parallel to the third side. This is the third side. So the triangle is ABC. AC is the third side. So PQ is parallel to AC, and then you got PQ equals to half of AC, because just now you have proved that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Which is the third side? Here AC is the third side. So these are the two midpoints. They are on the sides AB and BC. So this is the third side, and this is the triangle. So here PQ is parallel to AC and PQ is half of AC. Similarly, in this triangle, that is DAC, S and R, midpoints of AD and DC. Therefore, SR is parallel to AC, and then SR equals to half of AC. So you got it by the midpoint theorem. So you compare this 1 and 2. So from 1 and 2 you will get that PQ is parallel to AC, PQ is parallel to AC, SR is parallel to AC. That means SR is parallel to AC. So that means PQ is parallel to AC, SR is parallel to AC. That means PQ is parallel to SR. So you got PQ is parallel to SR. So from these two, from this and this. Then from the next pair, PQ equals to half of AC, SR equals to half of AC. So in place of half of AC, you can write PQ. So SR equals to PQ. So you got PQ equals to SR. Now you see, in this quadrilateral PQRS, PQ parallel to SR. So PQ is parallel to SR. PQ equals to SR. So PQ equals to SR. So you got that one pair of opposite sides, equal as well as parallel. They are the same pair, PQ, SR, PQ, SR. One is parallel, one is equal. So that means PQRS is a parallelogram. That means you have got the opposite sides equal. So to be a rectangle, you need one pair of, that means both the pairs of opposite sides equal. So you got it from this, because the figure has become a parallelogram. Now you need one more condition, that is you should make either any of the angle, that is either P or Q or R or S, to be 90 degree. So first you will take this point. From this two you will make the figure parallelogram just by making one pair of opposite sides equal as well as parallel. That time you will get this figure as a parallelogram. Then the last point will be, we will make any of the angles 90 degree. Then combining this, you will get that PQRS is a rectangle. Now, let us take the proof. So, let us take the triangle ABC. So, in triangle ABC, so P and Q, so P and Q are the midpoints of the sides So P is the midpoint of AB, and Q midpoint of BC. So and BC respectively. So the line segment, that is PQ, joining the midpoints of two sides of the triangle. So the triangle is ABC. So these are the two sides where you got the midpoints PQ. So by joining these midpoints, you have got the line segment PQ. So this will be parallel to the third side, and PQ is half of the third side. You have got it by the midpoint theorem. So therefore PQ parallel to AC and PQ equals to half of AC. So you got it by midpoint theorem. So this is equation number 1. Then similarly, you have got it that here in the triangle BCA, so here S is the midpoint of the side AD, R is the midpoint of the side CD, therefore SR, this is the line segment SR, you got it by joining the midpoints S and R. So this line segment is parallel to the third side. So the third side is AC because the triangle is ABC. So here similarly SR parallel to AC, then SR equals to half of AC. So this is also by midpoint theorem. Midpoint theorem. So this is equation number 2. You have got it by 2. So by comparing 1 and 2, so from 1 and 2, we get, so you will get, now you compare the equation of between these two. So PQ is parallel to AC, AC is parallel to SR. That means PQ parallel to AC, SR is parallel to AC. That means the two lines are parallel to the same line. That means the other two lines are also parallel to each other. That means PQ is parallel to SR. So from these two. So you got it from these two that PQ parallel to SR. And from these two equation, if you compare, so in place of half of AC, you can put PQ. So SR equals to PQ. So PQ equals to SR. Now you see from this, in this quadrilateral PQRS, PQ parallel to SR, PQ equals to SR. So PQ equals to SR. That means you have seen that the one pair of opposite sides equal as well as parallel. So the given figure PQRS is a parallelogram. So therefore quadrilateral PQRS is a parallelogram. So if this is a parallelogram, then the opposite sides are equal, which you need one of the condition to be a means rectangle. So the opposite sides are equal. Therefore, you have got that PQ equals to SR and PS equals to QR. So you can write opposite sides of parallelogram. Opposite sides of parallelogram are equal. So you got it as equal. So you got one of the condition. That means in a rectangle, opposite sides are equal. But you also need to show one of the angle to be means 90 degree. So now, how to show? You will know that the diagonals of a rhombus. So the diagonals are AC and BD. So these two diagonals, they are the diagonals of the rhombus ABCD. So you know that the diagonals of a rhombus bisect each other at that means right angles. So at this point you will get 90 degrees. So here it will be 90. So that means here at this point O, either at all the point here, that is at point O, either BOA 90 degree or AOD 90 degree, DOC 90 and BOC also is 90 because the diagonals of a rhombus bisect at that means bisect at 90 degrees. So that is why here you will get 90 degrees. Now here you will just do one thing. We will make this figure, that means parallelogram, SMOL. This figure you will make it as a parallelogram. If this is a parallelogram, as here the angle is 90 degree, so the opposite angles also will be equal. That time you will get this also will be, that is 90 degree. So now here in the quadrilateral, so in quadrilateral SMON, this one is N. So SMON. So S N O N. So you got it that here you have proved that Sn is parallel to M. Sn is parallel. So Sn is parallel to MO. Why? Because you have proved that SR is parallel to AC through the midpoint theorem. So since SR is parallel to AC, so that means Sn is also parallel to MO. Because SR is parallel to AC. Here, SR is parallel to AC. That is why Sn is parallel to MO. How you got SR is parallel to means AC? Because you have got it through the midpoint theorem. That means the line segment joining the midpoints of two sides of a triangle. The triangle is ACD and S and R are the midpoints of AD and DC. So therefore SR is parallel to AC. If SR is parallel to AC, that means SN is also parallel to MO. So here, since SR is parallel to AC. So you got it. Next, this is also a triangle. So the triangle is ABD. So here P is the midpoint of AB, S is the midpoint of AD. So by joining these midpoints, you got PS. So PS is parallel to the third side. So the third side is BD. Because the triangle is ABD, so these are the two midpoints P and S. So PS is parallel to means BD. If PS is parallel to BD, that means MS is parallel to ON. So MS parallel to ON because PS is parallel to BD. So PS is parallel to BD. So now if you see these two, so this is a quadrilateral MONS. In this quadrilateral, you have got that Sn is parallel to MO, Sn is parallel to MO, and then MS is parallel to ON. You have got that both the pairs of opposite sides are parallel. If both the pairs of opposite sides are parallel, then the figure is also called a parallelogram. If this has become a parallelogram, then the opposite angles are also equal. So here also you will get 90 degree. Why? Because the diagonals of a rhombus bisect at, that means right angles. That is why here a point of the angle is 90 degrees. So the opposite angle also will be equal. So this also will be, that means 90 degree. So therefore, SNON is a parallelogram. Since both the pairs of opposite sides are parallel, since both pairs of opposite sides are parallel, so therefore opposite angles are equal. Therefore angle MSN equals to angle MON. So angle MON. Why? Because opposite angles of a parallelogram are equal. Now this has become a parallelogram. That is why opposite angles are equal. And you know that the diagonals of a rhombus, this is a rhombus, these are the two diagonals, they will meet at, that means 90 degree. So here you have got 90 degree. So that means here, since opposite angles of a parallelogram are equal. So therefore angle MSN equals to 90 since angle MON is equal to 90. Why? Because AC is perpendicular to BD. Because this is a rhombus. Now, so this is, here you got, this one is say equation number 1. Suppose say, or this will be 3, and then this will be 4. So you see, in this tree, you got the opposite sides are equal in this, and from this you got one of the angle 90. So that is why you can now say that from 3 and 4, that means the quadrilateral PQRS is that means rectangle. Why? Because the opposite pair of sides are equal, and you got one of the angle, that means 90 degree. That is why from these two combined, you have got that the given figure PQRS is rectangle. So from 3 and 4, we get parallelogram PQRS. So PQRS is a rectangle. So here what we did first, they have given that the given figure is a rhombus, where P is the midpoint of AB, Q is the midpoint of BC, R and S midpoints of CDN and is DA respectively. And then you are to prove that PQRS to be that means rectangle. As we know that the diagonals of a rhombus bisect at, that means 90 degree. So here at this point, O here, that will be 90 degree. So what you did, you have used the midpoint theorem. So in the triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. So by joining these midpoints, you got the line segment PQ. So PQ is parallel to the third side. Third side is, that is AC. So PQ is parallel to AC. PQ is half of, that means AC. Similarly, in the triangle DAC, you have got S is the midpoint of the side AD, R is the midpoint of the side CD. Therefore, SR is parallel to AC. SR is half of, that means AC. So by comparing these two equations, you have got that PQ is parallel to SR, and then PQ equals to SR. So as one pair of opposite sides equal as well as parallel, therefore PQRS is a parallelogram where you got the opposite sides equal. Now to make a rectangle, you will have to show one of the, that means angle 90 degrees. So for this you have to make, say, either PQ, R or S 90 degree. So now this is a rhombus. So here the diagonals AC and BD meet at, that means 90 degree. So you have made this SMON to be a parallelogram. How? SN is parallel to ON. SN is parallel to ON. How? Because you made SR is parallel to AC. Then MS is parallel to ON. How? Because in this triangle, PS is parallel to DDB. That is through the midpoint theorem. So both the pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Therefore, SMON is a parallelogram. So that is why the opposite angles are equal. So here, since it is 90 degree, that is why this angle is also 90 degree. So by comparing this and this equation, so this parallelogram PQRS has become a rectangle. So it's proved. That's all for today.